Hello dear students, welcome back to Diksha Vedantu Foundation channel, and you are watching 99% in just 99 days for your final board exam. And today we are going to continue with the chapter Human Eye and Colorful World. Today we will discuss about some natural phenomena. So without any delay, let's start with today's discussion. First, let us discuss about the chapter configuration. We have already completed the part containing human eye. What all we have covered? We have covered power of accommodation, defects of vision, myopia, hypermetropia and presbyopia. These all concepts we have covered in yesterday's class. If you have missed that class, you can check in our channel. Okay, and we have going to discuss about natural phenomena. So what are natural phenomena are? Dispersion of white light, then atmospheric diffraction. In atmospheric diffraction we will going to cover twinkling of stars and advanced sunrise and delayed sunset. Also we will discuss scattering of light. In that briefly Tyndall effect and blue sky, why the sky is blue. Basically these are all we are going to discuss. So this half we have already covered yesterday. This half we are going to cover in today's lecture. It will be a very small lecture because the chapter is obviously very small, as you know. So first let us discuss about diffraction of light through a prism. So what is the meaning of that? So suppose we send a monochromatic light. Monochromatic light means light consisting of only one color. Single color light is called monochromatic, monochrome. Okay, monochrome, suppose you are only switching on a red light or a blue light or a yellow light. Any single light can be considered as monochromatic light. So suppose we are sending one monochromatic light through a prism, then as you can see that after coming out of the prism, it bends towards the base of the prism. Okay, this is called base of the prism. And in general the light bends towards the base of the prism. Okay, for normal prism there are some special cases, but we are not going to discuss anything like that. Now if you stretch the path, original path of the light, and if you trace the final path of the light, you can see that there is a angle. This angle is called angle of deviation. As we know, the angle between the final path and the initial path is called angle of deviation. This is true for in case of lenses, in case of we have learned that in case of mirrors. Similarly, this is also true for prism as well. Okay, but these are the topics that we will discuss in your second PU if you are from Karnataka board, or in your class 12th if you are from any other board. In class 12th this topic was taught in detail. Right now we will just restrict our discussion here that when the light is traveling through a prism, the ray bends towards the base. Okay, this is a single color. Now what will happen instead of single color if we send white light? White light is not a single color. White is not a single color. Okay, the example for this, the exact you can see that when you send the white light through the prism. Okay, when you pass the white light through the prism, you will see that after it comes out of the prism, okay, you can see 7 different colors. Not all the colors are clearly visible, but you can check that in a dark, perfectly dark room, in a perfect condition, using a perfect bright white light, these 7 colors can be discoverable. But in if our normal day-to-day life, if you do the experiment, you might not find all the 7 colors due to various factors. But if you do it properly, you will get all the 7 colors. And how can you remember all the 7 colors? I know you know all these things. So Vibgear, okay, or Vibgear, whatever you are familiar with. Vibgear, I was taught Vibgear. Some student used to tell Vibgear. Whatever you are familiar with, you can continue with that. Okay, what is the meaning of Vibgear? VIB, V is violet, I is indigo, B is blue, G is green, Y is yellow, O is orange, R is red. In this exact order you will get the lights. That's why this order is important. Okay, and if you see, the violet is at the extreme end, Okay, violet is at the extreme end of this color spectrum. This is called spectrum. Spectrum means where you get a multiple color. Okay, so you get violet at the extreme end of the spectrum and red at the extreme end another side. Okay, so violet is at the bottom side, red is in the top side. Normally this is the case. If you change the orientation of the prism, you can get different orientation as well, but normally if the prism is kept like this, always you should remember that violet is at the bottom, red is at the top, all the other colors are in between. Okay, the splitting of light into its component colors is called dispersion. So for example, white light splitting into its 7 component colors is called the dispersion of white light, right? So dispersion is basically dispersing them, separating them. Okay, so if you can separate a color, if it is a mixed color, okay, if you can separate them into its constituent colors, then that is called a dispersion. Okay, so white light basically consisting of all these 7 colors, okay, in a different ratio. So you can separate them into these 7 colors through passing through them through a prism. So that process is called dispersion. Okay, different colors of light bend through different angles with respect to the incident ray as they pass through the prism. So now why this is happening? What is the reason behind the dispersion? The reason behind the dispersion is that different colors bend differently. Okay, you will learn about in detail in your higher classes. Okay, in terms of refractive index, you learned about refractive index, that speed of light is different in different media, right? So that depends on the color. Okay, based on that different light bends by a different amount. Okay, so red light bends the least, where violet light bends the most. Okay, and that's why you can differentiate the colors. If it was a glass slab, there was once a question, if the prism is replaced using a glass slab, will you be able to see these 7 colors? Yes or no? Or explain it. So can you explain that answer in the comment below? I am very eager to know if you know the answer. Okay, even though that is not part of your curriculum, but that is a very interesting thought point. If you know the answer, don't forget to mention that in the comment. Okay, now as they pass through the prism, the red light bends the least while the violet light the most. So as I said, the violet light bends the most, whereas the red light bends the least. Okay, that's why you get this kind of spectrum, and this is called dispersion of white light. Next, now a natural phenomena of this. Okay, well, this was a laboratory setup, right? So when you are using a prism which is specifically made by a human, okay, and you are allowing the light to pass through it, which is also done by a human, so that was not a human, that was not a natural thing, that was done in a laboratory setup. Now we are familiar with this dispersion even before that was discovered in a laboratory through a natural phenomena known as rainbow. Okay, later on it was understood using that prism that actually the white light is consisting of 7 colors. That's why we see the rainbow. Now what is the basic physics behind the rainbow? Let us understand that. The rainbow is a natural spectrum appearing in the sky, okay, after a rain shower. It is caused by the dispersion of sunlight by tiny water droplets. Okay, tiny water droplets present in the atmosphere after a slight rain shower that cause the rainbow. Okay, you cannot see a rainbow in a dry day. If there was no rain, there is a very unlike chances of seeing a rainbow. Okay, because you need a good amount of presence of water droplets in atmosphere to be able to observe this thing. Okay, also clear sky. So after the rain, especially during after evening shower, just before sunset, if there is a shower and after the shower the sky clears, there is a high chance that you can see a rainbow opposite side of the sun. Okay, basically in the east side. Okay, if you look into the east, there is a chance that you might see a rainbow. And also, how many of you have seen rainbow? Don't forget to mention that in the comment below. And how many of you have never seen a rainbow? They also mention in the comment below. Okay, rainbow is not super common, but it is also not super uncommon either. Okay, both some people who are living in a city may not be have able to observe it properly because of lot of pollution nowadays, but if you go to a village side or a countryside where the sky is still clear, you can see rainbow after a rain shower, especially during summer days. Evening showers are very common in across country. Okay, during that time it is commonly visible. Okay, not it is also visible in other seasons as well. Okay, now a rainbow is always formed in a direction opposite to that of the sun. It is very, very important. If the sun is located on this side, you should look opposite to that of the sun. Okay, sun should be behind your head. That is very important, and sun should be lower, as close as possible to the horizon, so that the angle becomes. There are some conditions. Okay, that conditions are satisfied only when sun is behind your back and it is lower than your head. Okay, then you can see the rainbow in the sky. Okay, here the water droplets acts like a small prism. So water droplet acts like a small prism, as you can see here, and disperse the incident sunlight. Okay, first stage is here. Okay, the first stage is when the sunlight enters the water droplet, it gets dispersed into 7 colors. Okay, then it is reflect internally. So the light ray, after passing through this, they again gets reflected internally. Okay, once this internal reflection happens, okay, finally refract it again when it comes out of the raindrop. So after this process, again it comes out of here, and you can see that this is the violet light, this is the red light. So all the lights are now separated, all the colors are separated, so you can see all the colors in the sky. Due to the dispersion of light and internal reflection, different colors reach the observer's eye. So after the process is over, you can see different colors. Okay, and you can see that beautiful bow like structure. Okay, that is called refraction of that is called rainbow. Okay, that happens due to the refraction of light, and it is an atmospheric phenomenon. Okay, you can also see a rainbow on a sunny day when you look at the sky through a waterfall. This is also important. You can see a rainbow if you are visiting a waterfall, okay, during a sunny day. Okay, and if you are but the condition is that or through a water fountain with the sun behind you. You can see a rainbow if the sun is behind you, if you are looking through a waterfall, or if you are looking through a fountain, large fountain in a afternoon, just before sunset, or in and around 4-5 p.m. Okay, based on where you are, you can see the rainbow if you are watching through a fountain. That is also possible. That is not supernatural, but that is also possible. And if you remember, the rainbow looks like this. All the colors are not super clear, but you can see the red color is on the top side, blue color in the bottom side, in between there is yellow is very prominent. Okay, other colors, if you observe it very closely and using a high super good camera, then you might be able to see at least 4 to 5 colors. Not all 7 colors are prominent, because as you know, red and orange are very close to each other, so you cannot distinguish between red and orange. Similarly, violet and blue are also very close to each other, so you cannot even distinguish between violet and blue either. Okay, that's why you cannot see. Now if you see in this image, there is not only one rainbow, there is one more rainbow. Okay, this is called primary rainbow, this is the secondary rainbow. There are different reasons for that, we are not going to discuss in this class, but you should remember that the condition for rainbow, there are 2 conditions for rainbow, is that first of all there should be presence of water droplets in the atmosphere. Okay, secondly, you should look opposite direction to the sun. These are the 2 conditions for rainbow. These are the very important point, and the questions from these chapters are as usual very direct. They will ask you what is the dispersion of light. Okay, what do you need to observe dispersion of light? Secondly, they will say what is a rainbow, or they might say what are the conditions to observe a rainbow. That is very, very common. Okay, the conditions to observe a rainbow is, number 1, there should be presence of water droplets in the atmosphere. Secondly, you should look behind, the sun should be behind your head. Okay, or you should look opposite direction in the sun. Okay, but in your career you should should not look behind you, you should look always, you should look in the forward direction, right? So whatever you want to do in your life, whatever is your dream is, maybe it is achievable, maybe it is not achievable unless you are doing hard work, right? Now there are some inbuilt talent within you, and that talent can be come out if you are trying to test it. Okay, so Diksha is presenting a very important thing for all of you, that is Diksha Scholastic Aptitude Test, DSAT. Okay, what is DSAT? DSAT is basically constituting three parts, main three parts. What are the three parts? First of all, there will be a 60-minute lecture and doubt clearing session. So once you enter, you are registered for the DSAT, the link of this registration is given in the description below. From there you can register to DSAT, and after that you will be getting a 1 hour lecture. During the lecture, teacher will teach you some concepts based on your syllabus, based on anything. Okay, after the lecture is over, if you have any doubt, the doubt will be cleared by the teacher. After everything is cleared, they will give you a test question paper. Okay, it will be a very easy test. Okay, based on your test results, how you perform during that test, okay, there will be a counselor. That is the third part of the DSAT part. Okay, counselor will guide you for your future, whether you are more suitable to become a doctor or you are more suitable to become an engineer. Okay, based on your preference and based on your exam performance, the counselor will guide you what is best for you. Okay, either you should prepare for JEE, or you should prepare for NEET, or you should prepare for KSET. That will give you a clear idea, clear picture about your future. And if you don't want to look, you keep your future behind you, like you want to see a rainbow. The future is not always a rainbow. You have to face it, you have to see it like a rainbow, and for that you have to fill this form. The link is given in the description. I hope you will do it as soon as you are seeing this. Right now, let's start. Let's continue with our chapter atmospheric refraction. So next part of the natural phenomena are atmospheric diffraction. First part is atmospheric refraction. In the atmospheric refraction, what happens is that when light is traveling through our own atmosphere, Earth's atmosphere, atmosphere means Earth's atmosphere, as we know, the temperature of the Earth's atmosphere is not constant. The temperature near Earth's surface is very high, and as we are going up, the temperature decreases. Similarly, the density of air surrounding us is more compared to as we are going up. Okay, based on temperature and the density of air molecules, the refractive index of air varies. Okay, it varies as a layer. Okay, and after very few meters, the refractive index changes. Okay, so refractive index of air is not a constant, even though the variation is very small. Still, if you consider the exact layer on the surface of the Earth and say a layer 100 kilometers above, the difference is significant. Between two consecutive layers, the difference is not much, but the difference is significant when you are considering the refractive index around Earth and somewhere very far from Earth. Okay, even though the refractive index we generally say for air is 1, it is not exactly 1. It varies slightly from place to place, from height to height. Okay, now because of this we observe very interesting phenomena, that is twinkling of stars. Okay, if you have seen, if you look into the sky at night, you will see the stars are blinking as if they are blinking at you. Okay, now why that happens? Because the twinkling of the star is due to the atmospheric refraction of starlight. So from the star, some very small amount of light comes to our Earth, okay, and they keep on refracting through all the atmospheric layers. Okay, the starlight once entering Earth's atmosphere undergoes refraction continuously. So the process of refraction happens continuously. Okay, before it reaches Earth, the atmospheric refraction occurs in a medium of gradually changing refractive index, thus that gives rise to the twinkling of stars. Okay, so if you see, the stars also does not appear to its exact position because of the atmospheric refraction. It appears slightly above than its actual position. Okay, based on where you are on Earth, star might appear slightly above or slightly below. Okay, now for us, we live in the northern hemisphere. For us, the Earth, the stars appears in the slightly above position than its actual position. Okay, and this position is also not fixed because of the refractive index of the air continuously fluctuates, especially in the region where it is close to the Earth. okay, and far from Earth, okay, the refractive index varies continuously, and based on that the ray of light, the apparent position of the star continually changes. Okay, that's why this appears that stars are twinkling. It is not actually twinkling. The apparent position of the star changes slightly, it goes up and down. That's why we perceive this as if the star is twinkling. Okay, twinkling is nothing but a refractive phenomena. If you go outside Earth's atmosphere, okay, where Hubble's Space Telescope is located, if you go there, there will be no twinkling. Okay, stars will be static. If you go to moon, stars will be static. There are no atmosphere in the Earth, so stars will not twinkle there. Okay, next is why does planet does not twinkle. So if you see some objects in the night sky, okay, you might find one or two objects which are slightly brighter than normal average star, and they are not twinkling. Okay, those are basically our planets. Okay, we know that our solar system has 8 planets. One of the planets might be Mercury or Jupiter or Saturn. You can see them from Earth based on the location, based on the year. You can even see them at night. Okay, sometimes evening or in the morning also there are different stars available. We call it morning star, evening star. There are different stars. Actually they are not stars, they are planets. Okay, now why do they not twinkle? Because the planets are much closer to the Earth. That is one thing, and are thus seen as extended sources. So for example, the stars are so far, they are considered to be a point object. Even though they are much bigger than our planet, they are so far apart, their sizes are actually considered to be a point object. Okay, but planets which are much closer to us appears to be a extended object. Extended object means they are not a single point, they are multiple points. Okay, multiple points means all the points are sending lights towards us, even though their position is changing. Okay, because multiple sources are sending light towards us, their exact apparent position is not changing too much. Okay, even if they are changing within themselves, so that the boundary of the planet does not change. Okay, so for example, if suppose this is the planet. Okay, this is the planet. Now this point is changing, this point is twinkling, assume. Now we said that planet is a extended object, so that's why we are drawing a circle instead of a point like the star. Okay, now this position is twinkling. How it is twinkling? It is twinkling from here to here. Okay, now another point is here, it is twinkling here to here. But overall the planet is located here only. So even though these individual points are twinkling, we are not seeing the twinkling, we can see only this outside contour. Okay, we can only see this object, right? That's why planets do not twinkle. Okay, let's read once more. If we consider a planet as a collective of large number of point-sized sources of light, the total variation in the amount of light entering our eye from all such points, okay, will average out into a 0, thereby nullifying the twinkling effect. So even though the individual points are twinkling, all such points, whoever is twinkling, if you average them out, they will not twinkle, because they are not a single point, there are extended points. Even though they are also small, but they are not super small. Okay, stars are so far away, you can consider them to be super small. Okay, next part, advanced sunrise and delayed sunset. So in the morning when you look into the sun just before sunrise, okay, you might find a red sun rising in the sky. Okay, the red sun, you might obviously if you are living in city, probably you may not have seen that. Okay, you have to go to a river front or somewhere you can see an open sky. Okay, just before sunrise you can see a red sun appearing in the sky. Okay, and that actually happens 2 minutes before actual time of the sunrise. If you see, if you have an app to track the sunrise and sunset, then this happens 2 minutes before sunrise. And same place, if you go and look into the opposite direction, that is in the west direction, okay, then you will see even after the sunset has happened, you can still see a reddish part of the sun. Okay, that is called advanced sunrise and delayed sunset. Because of that, our daytime is 4 minutes longer. okay, because apparent position of the sun is when even if the sun is actually below the horizon, the sun still appears to us like a ghost, like this. Okay, so even if the sun has gone down the horizon, because of that atmospheric refraction, it appears somewhere above the horizon. Okay, and this is basically called the apparent position of the sun. Okay, and this happens predominantly just before sunrise and just after sunset, so be very careful. Okay, so after actual sunset, because of the atmospheric refraction. The reason behind that is atmospheric refraction, because as the sun is traveling, it is not traveling in a straight line, they are traveling in a curved path. So now if you end up here, if you trace the end path of the light, you will get an apparent sun. Okay, and that sun is actually appearing reddish in light, in color. Now if you know the answer why the setting sun and rising sun appears red in color, do mention that in the color comment below. That was also interesting topic. I will not discuss that, this is not part of the syllabus, but you can answer that part. I will briefly explain that in our next part. What is that? That is scattering of light. Okay, light is not constant, they do scatter. What is the meaning of scattering? Okay, scattering means, suppose light has hit one particle present in our atmosphere or somewhere. Okay, in the space also you know that there are a lot of particles present from asteroid, from broken planets, etc. Okay, from our satellites. So those particles, once the light hit that particle, light changes its direction. That is called scattering of light. Okay, and once the light scattered, this object is visible. This object becomes visible, and that effect is called Tyndall effect. Okay, what is Tyndall effect? The phenomena of scattering of light by colloidal particles gives rise to the Tyndall effect. Okay, colloidal particle means, for example, if you add something into the water, for example a salt, it dissolved quickly. But if you don't add salt, if you add say flour, okay, gram flour or any type of flour, this does not dissolve quickly. Okay, some of the particles remain suspended in that fluid, right? That is called colloidal solution. So if you torch that colloidal solution, the particles in that colloidal solution appears bright. Okay, and that happens because of the scattering of light by those particles. Now naturally there is one example of Tyndall effect. If you have seen such scenery, if you are visiting places like different forest areas, then you might see during the afternoon or during the morning, you might see this kind of beautiful scenery, right? This is happening because of Tyndall effect. Now the dust particle present in the air, they are behaving as a colloid, okay, and the sunlight is the source of light, and because of the Tyndall effect, this misty kind of things is happening. Okay, so this mist are actually Tyndall effect, due to Tyndall effect. If there are no dust particle present in the air, you will not be able to see this. Fog or smog is also part of type of Tyndall effect. Okay, where smoke particles and air particles, water particles present in atmosphere, they also scatter light. Because of that, the smog and the fog appears. Okay, slightly different but similar, on the similar line. Okay, now let's move on to the next part. The color of the clear sky. Why the sky appears blue? So this is a very common question from this chapter. Why does the sky appears blue? First of all, let us understand why the what is happening here. The molecules of air and other fine particles. Here the air is also taking part. In Tyndall effect, air was absent. Okay, it was only done by the colloidal particles. But in this case, even air particles are also involved. So molecules of air and other particles in the atmosphere have size smaller than that of the wavelength or visible light. So if the size of the object is smaller than that of the visible light, then you can see that these are the more effective in scattering light of shorter wavelengths at the blue end than light at the higher wavelength. Okay, so smaller your size is, you can scatter smaller wavelength. Okay, so now if you consider that particle, that things that we remember, V I B G Y O R. Okay, this has the highest wavelength. okay, and this is the lowest. Now the intensity of amongst violet, indigo and blue has the highest intensity among these three. Okay, intensity is better. Okay, so what is happening? Sunlight, which is basically a white light, when it enters our atmosphere, it gets scattered by the air particle, dust particle, small finer particles. Okay, they all scatter this white light. Okay, now what is happening here? Suppose there is a particle, air particle. Okay, sunlight enters. Okay, and the sunlight hits that particle. Now out of all the colors, smaller wavelength, that is violet, indigo and blue, they scattered most. Scattered most means their angle changed the most. Okay, whereas the red, orange, yellow, they do not scatter, they go away like this. Now you are standing here. Okay, this blue light enters your eye, whereas the red light do not scatter, they go straight. Okay, they go to the other side. Okay, and because this sunlight here, the sunlight is entering, after scattering it, the blue light enters your eye, you feel that the sky is blue. Basically what is happening, sunlight is coming. Okay, after the sunlight comes, hits the particle, blue light bends, comes to you, and the red light goes straight. So you see that, okay, the sky appears blue. Clear? From now on, you don't say that sky is blue. Basically it is due to the scattering of light. If there was no atmosphere, if there was no scattering, then sky would not be blue. You can see the dark black sky even during the day. Okay, very interesting, right? Now the red light has a wavelength about 1.8 times greater than that of the blue light. Thus, when the sunlight passes through the atmosphere, the fine particles in air scatter the blue color, shorter wavelength more strongly than red. Now, the question, when I was a student and no teacher was about to explain it to me, because I think violet has the smallest wavelength. So violet should scatter the most compared to blue. So why does the sky does not even appear violet? Okay, why it appears blue? Blue and indigo are somewhat similar, so you cannot differentiate between blue and indigo when they combine together. Okay, it mostly blue. Okay, and even some people cannot even distinguish between indigo and blue because they are so close to each other. Okay, so that is okay, that is a thing. But violet is not like that. Violet is easily identifiable. Okay, why does we don't see violet? So there are mainly two reasons. First of all, I gave you one reason, that violet intensity of the violet is very small. That means the constituent which covers the white light, sunlight, okay, the component of violet light is very small in the sunlight. Okay, so the sunlight has a very small amount of violet in it. Okay, but blue is the major contributor. Blue, red, they have very high contributor. Even yellow also has a very high concentration. Okay, and the violet light, after scattering, the angle might not reach you. They scatter so much. Okay, they might even go almost in the other direction. So, but blue is having this wavelength such that it comes directly towards you. Okay, so sunlight is coming. Okay, after refraction, blue is coming towards you, violet even going in some other direction, you may not able to see it, and red is going straight. That's why sky appears blue. Okay, violet, basically it has main two reasons. One reason is that the intensity of the violet light presence in white light is very small. Secondly, it scatters more than the blue light, and it may go in other direction, even not even present in the scattered light. Okay, also one more reason is that the ocean appears blue. Okay, the color of the ocean water is blue, but if you take that water in your hand, you will not see they are blue. Why so? Because oceans also reflect the sky. You have to understand that the color of the ocean is not an indigenous color. No one has went to the ocean and mixed some blue color or ujala into it. Okay, so no one has taken the blue color and mixed it into the ocean. It is basically reflecting the sky. Okay, that's why it appears blue, right? Now next, is few examples. All the questions coming from this chapter are straightforward. As I said, they will ask why the sky appears blue, why what is Tyndall effect, what is atmospheric refraction, why the stars twinkle, why do the planet don't twinkle. So all the questions we have discussed in detail. Now let us see few higher order thinking skill about MCQs. Okay, what are these? So first this question, what is this question? A prism ABC with BC as base is placed in different orientation. A narrow beam of white light is incident on the prism as shown in the figure below. In which of the following cases after dispersion the third color from the top corresponds to the color of the sky? So third color from the top, very very important, third color from the top corresponds to the color of the sky. So what is the color of the sky? Color of the sky is blue. Okay, now they have said third color from the top. So from the top means it has to be in the order of wave G or. Right now we know that if the prism is oriented like this, okay, after diffraction red goes up, okay, and blue is the violet is at the bottom and blue is somewhere here. Okay, so this is and indigo is in between. Okay, so you see that this is third color from the bottom. So you have to get a light such that violet appears first. Now when you will get that? So this is only possible when you have oriented the prism in the wrong direction, that is opposite direction. Now what will happen? The red light as usual will scatter the least, it will go like this, and violet light will scatter the most, it will go like this. So blue light will be somewhere here. Okay, so it will be 1, somewhere 2, this is 3. So only from this orientation you can get blue light as the third color. Be careful when you are answering such question. This is a hot question. This question came in your previous year. Okay, so the answer will be orientation number 2. Orientation number 2. Okay, clear? Why not option A? Why option 2? You have to be clear in your head to answer such questions. Next question is another question. The danger signal installed in the top of a tall buildings are red in color. This can easily be seen from a distance because among all the colors the red light. So as we see, the red light scatters the least. So that's why it can be visible from a very distant, from a high distance. Okay, so because if you are using the blue light, as you know, blue colors scatter the most, so it will go towards the ground. Okay, and it will someone from the ground he might see the blue color, but not from someone who is on the same level. Okay, that's why the red color traffic signal or danger signal, any kind of danger signal, they always appear in red, not because it is the color of the blood, it is because red light is visible from afar. Okay, so it absorbs the most by the smoke or fog, it scatters the least by smoke or fog. Okay, this is the answer. Okay, it's scattered by some. I have seen a question where they have even given you the option that it resembles the color of the blood or it is the danger sign, that's why it is danger sign. Okay, then that is not the reason. Even some students answer that. The reason is that it scatters the least. Now if you don't want to scatter, if you want to become like a red light, then the only option that you have is to take this Diksha Scholastic Aptitude Test, that is DSAT. What is DSAT? Again I am explaining it to you. There will be 1 hour lecture and doubt clearing session. Once the doubt clearing session is over, then you have to appear for a test, okay, based on that particular lecture. Once the test is over, based on the test result, there will be a counselor. He will guide you that what is your best career option, whether you should focus in future for JEE or you should focus on NEET. What is JEE? JEE is joint entrance examinations. Maybe you have heard from your seniors, from your brothers. Okay, elder brothers, JEE is basically to take admission in top IITs across India. NEET is basically when you want to become a doctor, and KSET is a engineering exam for the students in Karnataka. Okay, and only thing that you have to do, you have to fill up this form. The link of this form is given in the description below. If any parents is watching or a student who are very confused about their future, they should definitely try this out. It might help you to find a secure future, right? Also, if you liked our videos, if you want us to continue, don't forget to like our videos, share it with your friends, and subscribe to our channel. I will be back with more such videos soon. Tomorrow there will be a revision class along with Jasmine ma'am. Yes, Jasmine is coming tomorrow, so I will be discussing Jasmine ma'am about this chapter's revision. Okay, till then, bye.